For a simple pendulum having time period t, the variation of kinetic energy with time t is represented by. So here basically in the options, the graphical representation between kinetic energy and time period is given. So if we draw the simple pendulum where this is the equilibrium position, and if the bob is displaced by an angle say theta, angular displacement, you can draw the mg in the downward direction and the restoring force and the component of mg, this angle is theta, and the component of mg cos theta, and this direction which is responsible for the restoring torque or force can write as a mg sin theta. You can also write the equation of motion, that is d2 theta by dt square plus g by L for small angle, that is theta basically less than 15 degree, will be theta equals to 0, and the solution of this term will be theta function of t equals to theta naught initial amplitude into cos omega t, where omega is basically, you can say, that root over g by L, and the time period that we know t equals to 2 pi by omega, that means root over L by g. Now all those things that we can apply here is about the solution. So we can write that x function of t equals to x naught cos omega t. So this is basically the cosine graph. Here we want to calculate the kinetic energy, so it basically the velocity. So the differentiation of dx dt, that we will get as a minus x naught omega sin omega t. So all you know that the sin omega t graph should be drawn in this way, where there is 0, pi, 2 pi, like this. Now here we want to write or draw the kinetic energy, which will be half m v square. So that is basically half m x naught square omega square into sin square omega t. So that means the part which is negative amplitude, say minus a or minus x naught, say plus x naught, so due to this square sign, this negative signature for kinetic energy will be positive. So basically minus square will be positive, and obviously the plus square will be positive. So if you want to draw the kinetic energy versus the time period, then you can say for this cycle it will be up. Now for the negative cycle also it will be up, and it will be t by 2, and the fulls, for the full it will be t. So you can say that option number 1 is not right because it's a straight line. Option number 2 is also not right because the square is given, so the negative part should not be there. Option number 4 is also not right because the negative part is there, because there should be a square sin square omega t. So option number 3 is right. Thank you.